Alright, so I want you to take a look at this here real quick. We have the sine of 2 pi over 3 plus 5 pi over 6. And then we have the sine of 2 pi over 3 plus the sine of 5 pi over 6. So what do you think about this?
Looks like a distributive property.
Looks weird.
Yeah, it kind of looks like the distributive property.
I'm guessing if we go and evaluate both, we'll get the same thing.
You're guessing that we'll get the same thing, okay? What do you guys think? Do you guys think we'll get the same thing?
I'll do double dash, and I'll say no.
Okay.
I'll say so. We will.
Just kidding.
Well, I put on here use your calculator. The fact of the matter actually is you don't have to use your calculator to evaluate these because it's all unit circle stuff. Even the first one. So take a minute here and figure out what each of these equals. Okay, so thanks to Logan, we've got some work here. Notice here, if I were to do part A, you add the 2 pi over 3 and 5 pi over 6, you get 9 pi over 6, which is 3 pi over 2. And you guys know that the sine of 3 pi over 2 is negative 1. If I did this over here, though, did each sine separately, the sine of 2 pi over 3 is root 3 over 2. The sine of 5 pi over 6 is 1/2. So if I add those together, it's just 1 plus the square root of 3 over 2, and that's about 1.35 or so. Okay, but it's not negative 1 for sure. Okay, so these are not equal. Okay, these are not the same thing. So we have to have some kind of a method in order to be able to evaluate things like this, where we're adding two angles together. And you say, well, why? We just added them and we got 3 pi over 2. The fact of the matter is, we're not always going to get an angle that's on the unit circle. Okay? We're going to use these angle sum and difference formulas to be able to find values of trig functions for angles that are not on the unit circle. Okay? So let's take a look at this. Here we have 6 formulas. And you can see they're in pairs. Here are the 2 sine formulas, the cosine formulas, and the 2 tangent formulas. Alright? And you can see some similarities. Let's look at the sine ones first of all. The sine of u plus v is sine u cosine v plus cosine u sine v. Notice u is one of the angles, v is the second angle that you're adding together. Okay? You should know these formulas here. Okay? And we're going to use them a lot over the next couple days, so you'll get the hang of using them and know them better. Sine of u minus v, notice the formula is identical except for its subtraction in the middle. Okay? So really, if you just remember the one structure, and then when sine is adding the angles, it's addition. When it's subtracting the angles, it's subtraction. Okay? Then we have cosine. Cosine of u plus v is cosine u cosine v minus sine u sine v. And the cosine of u minus v is cosine u cosine v plus sine u sine v. Alright? So notice the similarities and differences here. Sine uses a mixture of sine times cosine, cosine times sine, and the operation is the same as what you're doing with the angle. Cosine has cosine, cosine, sine, sine, but the operation will be the opposite of what you are doing with the angles.
These tangents, just
okay?
like tangents. I mean,
Tangents, all tangents. Yeah. Tangent of u plus v is tangent u plus tangent v over 1 minus the product. Okay? Tan u minus v is tangent of u minus tangent of v over 1 plus tan u tan v. So here, once you remember the structures, notice the numerator is the same operation as you're doing with the angles. The denominator is the opposite. And actually, if you know your sine and cosine, tangent sine over cosine, that's not a direct here, but the sines work the same way. Sine, the sines were the same. Tangent, the numerator, was the same. The denominator is opposite, just like in the cosines, the signs are the opposites. So that might help you kind of keep these straight a little bit. Yeah.
So what's like a practical use for these? It seems like there's a lot more trouble in this would. Like is it like whenever the thing you're adding would be something that's not on the unit circle, so it would be like weird or
Yeah, and we're gonna look at an example here in a minute
Five.
at finding the sine of 75 degrees.
oh okay.
Okay? Let's do this example though that we started with, which in this case you're right, it doesn't make any sense to do this other than to illustrate the point.
Alright.
Because we could just add them and we get something on the unit circle. But just for practice, let's go ahead and do it. What is u in this case?
2 pi over 3.
Good, u is the 2 pi over 3. V is
5 pi over 6.
5 pi over 6. So, using our formula that we have up here, that one, we're going to do the sine of 2 pi over 3 times the cosine of 5 pi over 6 plus the cosine of 2 pi over 3 times the sine of 5 pi over 6. Really, guys, once you've memorized the formulas, you've done the hard part. Because at this point, we're just plugging numbers in. Okay? We know our formula, we know our unit circle. These are actually really easy. Okay?
Just use your calculator.
Well, that's the whole point. We're going to get exact answers without using the calculator. Now, what's sine of 2 pi over 3? You guys know this, it's unit circle.
And then wait.
Root 3 over 2.
Root 3 over 2. What's cosine of 5 pi over 6?
It is 1 half.
Half.
No, it's
Root 3 over 2.
It's over 2.
No, it's not. It's
Root
negative
3 over
1
2.
half.
Negative.
Negative root 3 over 2.
There we go.
Yeah.
Negative root 3 over 2.
Did you answer?
Okay.
No, waiting for you guys.
Alright. Negative root 3 over 2. Now, cosine of 2 pi over 3.
2 pi over 3 is 1 half.
We're in the second quadrant, right?
Yes.
So
Yeah.
cosine is
Negative.
negative 1 half. And sine of 5 pi over 6?
Positive.
Positive 1 half. Good. Alright, so if we multiply these and put them together, we get negative 3/4 plus a negative 1/4, which happens to equal negative 1.
Wait.
Whoa, 2.
Which, isn't that what we said it was supposed to be?
Yeah.
Because the angles add up to 3 pi over 2 and the sine of 3 pi over 2 is negative 1?
Mind blowing.
Okay? So it
Round of
works.
applause.
Yes.
So isn't this only viable if the things you are adding by are on the unit circle?
No.
True. Or unless we know them.
Right.
So like, once we used this to get one of the things on the unit circle and we knew what that value was, then we could use that in combination with other things on the unit circle to get other sums and could keep going and going and going. So, okay? Now let's try one that's not on the unit circle.
No.
Find the exact value of cosine of 75, whether you like it or not.
Wait.
Alright? Now, this is a case here, guys, where the degrees are a lot easier to work with. Because what you need to do, if you're supposed to find the exact value, that means you're not using your calculator and getting some decimal that you're rounding. Exact means exact, so it's in terms of radicals. Okay? Now, cosine of 75, what you need to do is come up with some combination of angles that you do know from the unit circle that will make a 75-degree angle. So it's going to be cosine of what
30 and 35. Boom. Done.
30 and 45.
Wouldn't
Well, but 50 and 25 aren't on the unit circle.
Wait, yeah, you're right. No, 25 is better.
Okay.
You guys
Alright, so we have 30 and 45.
Did I say that?
So guys, listen. Now we've identified u and v, and now we can use the cosine sum formula. Now, here's kind of the cool thing about this. This isn't the only combination you could use. Alright? You might have done, I don't know, let's see, 135 minus 60.
That seems like a lot.
You could have done that. Alright?
Oh, and then you did the other one.
And then you would have used cosine of u minus v.
Okay,
Yeah.
okay.
Here's the thing. You just have to find one that works. Okay? So it doesn't matter if it's necessarily the one that I would have seen, as long as they add up to 75, it'll work. Okay? So now we're going to use our formula. This formula right here. So we have cosine of 30 times cosine of 45 minus, good, sine of 30 times sine of 45. Okay? What's cosine of 30?
Root 3 over 2.
Root 3 over 2. Come on, these are all first quadrant. We should know these ones real well. Cosine of 45?
Pi over 4.
That is pi over 4. What's the cosine?
Radical 2. Yeah, stupid.
Radical 2 over 2. Let's be kind.
That's not, weren't you?
No, this kid is like in the morning.
What's sine of 30?
Oh, I got this.
I'm not going to answer anymore.
No, it's 1/2.
It's 1/2. There you go. And sine of 45?
I was on the video too.
Come on, guys. What's sine of 45? Everybody should know this one.
1/2. Root 3
Root 2 over 2.
See, I knew it though, I just didn't want to say that.
Alright, so look. We have root 6
Wait, Mr. Hudson.
over 4 minus root 2 over 4. So it's minus 6. It's, root 6 minus root 2 all over 4.
Oh, root 6.
Okay? Square root of 3 times square root of 2 is root 6 minus root 2, and they're both over 4. So I just put them together into one big fraction.
So do you look at these videos and do you sometimes laugh at them?
Alright, so we've got that one, cosine of 75. Let's try one in radians. Okay? This one's a little bit more challenging when we're dealing in radians, because you got to think about, alright, I've got to combine, pi over 6s and pi over 4s and pi over 3s and pi over 2s to get a pi over 12. Okay? So I want to get a pi over 12. Now a pi over 12 is smaller than pi over 6, in case you're wondering. So we're going to need to use subtraction, right?
Right.
So what angles here, the key here is going to be, if I'm going to subtract them, I'm going to have to get common denominator, alright? So what denominators could I put together and get a common denominator of 12?
3 and 4.
6 and 4, 3 and 4, okay? There's a couple of different possibilities,
6
alright?
and 6. Yeah, but if it were 6 and
It's
2,
not
you just
6
go up
and
to
6.
6.
Yeah, if it were 6 and 2, we'd use 6. If it were 6 and 6, we'd just use 6. So we're going to use either something pi over 6 and something pi over 4, or something pi over 3 and something pi over 4.
Okay.
I say pi over 3 and pi over 4.
Yeah.
Okay? How would you do that?
I figured you use pi over 6 and pi over 6.
So you do. Anybody else can jump in if they want to help out.
No,
that's
okay,
fine.
you
You got
got
this one,
this.
bro.
No, this is gonna take a while. Like, this is gonna take a real long while.
Say
for my
pi
brain
over
to
3
catch
and
up.
pi over 4.
Pi over 3 and pi over 4. Pi over 3 is bigger than pi over 4.
Well, you would
Pi over 3
you would
minus
make it
pi
into-
over 4.
Okay, there we go. Okay.
Just
Use your
4
brain.
pi over 12.
Okay. Yeah, check that out. You're going to have 4 pi over 12 minus 3 pi over 12.
Yeah.
That's going to give you pi over 12. Okay? Now, again, there's more than one way you could have done this. You could have done pi over 4 minus pi over 6. Okay? If you think about it, what is pi over 12 in degrees?
See, I would have used it.
That's a great question.
180 divided by 12.
Is that the bell?
15.
It's 15 degrees, yeah.
Close.
Okay?
16.
So 15 degrees.
Yes, Cannon.
Really, we're finding the sine of 15. And here's the thing, guys. It may, if you're really stuck on one, maybe converting it 2 degrees would be helpful. Okay? Now, it's not terrible to try to do it this way either, but it might be helpful to convert it 2 degrees. From there, it's just plug and chug. Put it in your formula and you got it. Okay? Alright, so using our formula with our difference formula for sine, it's sine of u cosine v minus cosine u sine v. Alright, so we have sine of pi over 3 times cosine of pi over 4 minus cosine of pi over 3 times the sine of pi over 4. Okay? At this point, you're just using your unit circle. Okay? So what's our sine of pi over 3?
What are your answers in like?
No, root 3 over 2.
Well, this is already in radians, so
Root 3 over 2.
it'd be root 3 over 2.
2 pi.
And cosine of pi over 4?
Root 2 over 2.
Root 2 over 2 minus, what's cosine of pi over 3? 1/2. And sine of pi over 4?
Root 2 over 2.
Root 2 over 2. Okay? So we have root 6 over 4 minus root 2 over 4, which is root 6 minus root 2 all over 4. Remember, you can't combine those radicals because the radicands are different. Okay? Now, notice here, we got the same thing for sine of pi over 2 as we did for cosine of 75. Okay? Does anyone know what pi over 12 is in radians? Or in degrees?
75.
No?
Oh, it's 15.
It's 15.
It's the reference.
It's not the reference angle.
Because just how much it takes to get to 90.
It's how much it takes to get to 90, so they are
Complementary.
complementary. What identity did we just show? The cosine of 75 we just showed equals the sine of 15,
Oh, so it's cosine squared instead of cos.
which is the sine of 90 minus 75,
Oh, this is co-function?
the cofunction identity, okay?
Oh, right.
So here you actually see the cofunction identity illustrated with something other than our unit circle angles, okay? So that's just an aside from what we're looking at with the formulas, okay? Any questions about using the formulas here? Okay. Really memorizing them is the hardest part of this. Then it's just plugging it in and remembering your unit circle, okay? Here's another case of kind of a different way we can use these formulas. In this case, we actually don't know what the angles are. All we're told is that the sine of u is 4/5 and u is between 0 and pi over 2. So what does that mean? U is where?
It's in the first quadrant.
It's in the first quadrant. Very good. Okay? And then we're told that the cosine of angle V is negative 12/13, and it says V is between pi over 2 and pi, so that means that V is where? Second quadrant, okay? Cosine was negative, so we knew it had to be second or third, and this confirms that it's the second. So now when we try to use our formula to find the exact value of sine of u plus v, all right, we're not going to use inverse trig functions and get the angle and then do that. because we would have to round at some point, okay? And then we wouldn't have the exact value anymore. Okay? So we're going to do it with our formula. But as we go to plug it in, sine of u is 4/5 times the cosine of v, we were told, is a negative 12/13, plus we have cosine of u times sine of v. We don't know what those are. Okay? So how could we go about finding what those are?
Wait, you do have.
Yes.
Because you know that sine squared plus or minus 1, I don't remember which one it is.
Plus.
Equals cosine squared.
Okay. Sine squared plus cosine squared is 1. The Pythagorean identities. Okay? Very good. The Pythagorean identity. So if I need cosine of u, then I'm going to use sine of u squared. Okay? So cosine squared is 1 minus the sine squared. Well, sine is 4/5.
So it's 1.
So it's 9/25, right? 9/25 if we square it. Okay?
Wait, where'd you get 9/25?
We squared 4/5. Sine squared, okay?
You squared 4/5. Wouldn't that be 16 over 25?
Oh wait, yeah. 16, sorry. Whoa. There we go. I was getting ahead of myself. When I subtract 16/25, what do I get? 9/25.
Oh.
There we go. Okay? So I know that cosine squared is 9/25. So I square root, and I know that cosine is 3/5. Now, because I square rooted, it could be plus or minus 3/5. Which one is it here? Plus, because it's in the first quadrant. Very good. Okay? We're in the first quadrant. That's why they included this part of where the angle was. Okay? So now I can plug in 3/5 for cosine of u. This first part is a negative 48/65. So now I just need to figure out what sine of v is. Alright, how am I going to figure out sine of v?
Sine squared equals 1 minus cosine squared.
Okay, good. If I use this, notice I need to use the cosine of v because I'm trying to find the sine of v. So sine squared v is 1 minus negative 12/13 squared. Be careful if you use your calculator here. When you square a negative, you always end up with a positive. If you punch it into your calculator wrong, you could very easily have them tell you that it's a minus 144/169. Okay, and then you have a double negative and you end up adding, alright? So be careful with this. I know that the negative's going to get canceled out. Alright, so sine squared v is 1 minus 144/169, which is 25/169. Okay. And sine of v then equals what?
5/13.
Very good. 5/13. Is it positive or negative?
Negative. Positive.
Why is it positive?
Because. Oh no, it's negative.
It's negative.
Why?
It's in the second quadrant.
It's in the second quadrant, so sine is,
Fine, all students, yes, positive.
so it has to be positive. Second quadrant, sine has to be positive, okay? So now we plug in that 5/13 for sine of v. negative 48 65ths, plus 15 65ths. That is a negative 33 65ths. Okay? So, here's the cool thing. We still have no idea what the angles actually are, but we know what the sine is. Okay? And sometimes that's all we need to know. Okay? By the way, it makes sense here that sine is negative, because if you have a first quadrant angle and you have a second quadrant angle and you add them together, chances are you're going to get a third quadrant. It's still possible that it still ends up in the second quadrant, but you're more likely to get a third quadrant angle. So it makes sense that sine is negative here. Okay? One last example here. Okay? This one, at first glance, looks a lot more complicated than it is. Okay? Because we have these arc functions. The arc functions are the same as the inverse functions, okay? Now, before we dig into this one here, I just want to remind you of the ranges for our different arc or inverse functions, okay? Remember we had arc sine, we have arc cosine, and we have arc tangent. Okay? Now, in order to make these functions, the sine, cosine, and tangent, 1 to 1, remember we had to limit their domains.
Yeah.
Okay? So sine, if you remember, we limited it so it went like this. And it was 1 to 1.
And it's for arc sine.
So that we could then reflect it across the line y equals x, so we get arc sine. Alright, and when we did that, where we cut it off was at negative pi over 2 and positive pi over 2. Okay? Now, cosine was a little bit different. Okay? Cosine, we were actually able to start it at 0 and go all the way over to here, okay? So for arc cosine, we went from 0 over to pi.
This is the domain, right? For the range.
This is what we limited the domain of, so that's what the range of our inverse function became. Okay?
Right.
So 0 to pi is our arc cosine. Okay? Now, arc tangent, remember tangent has those asymptotes at pi over 2 and negative pi over 2, so it looked like this. Anyways. Hello. Okay? But we limited it again to having this range from negative pi over 2, but not equal, up to approaching pi over 2. Okay? This is why, guys, when you hit the inverse sine button on your calculator, it always gives you a value between negative 90 and 90, or negative pi over 2 and pi over 2. But when you hit inverse cosine, it'll always give you a number between 0 and pi. Okay? And when you hit inverse tangent, it always gives you a number between negative pi over 2 and pi over 2. Okay? Now, with that being said, let's take a look at this that we're trying to do here first. Okay? It says we want to take the cosine of the arc tangent of 1 plus the arc cosine of x. Alright? So, the first thing that I would do when approaching this problem is go ahead and evaluate what I can. Alright? We can evaluate the arc tangent of 1. what angle would that be?
Pi over 2, pi over 2.
No? I think you're thinking of square root of 2 over 2, square root of 2 over 2.
That.
Okay, what angle has that point?
45.
45, or pi over 4, okay? So, I can rewrite this as the cosine of pi over 4 plus arc cosine of x. Now, we don't know what x is, so we have to just leave that as arc cosine of x. But, now we've simplified this a little bit. Okay?
You know, you work the formula.
Now we can work with our formula. Now, cosine of the sum of two angles is cosine cosine minus sine sine. Alright? So we have cosine of pi over 4 times the cosine of the arc cosine of x minus the sine of pi over 4 times the sine of the arc cosine of x. Okay. Now, what can we simplify?
Well, cosine minus sine of pi over 4 will equal 0.
Root 2 over 2.
No.
Yeah.
What's root 2 over 2?
Well, isn't
Cosine of pi over 4 and sine of pi over 4.
Okay, those are both root 2 over 2.
So we can just get those out of the way right now.
Well, we can't
Now, you
do
can't
that.
actually subtract them because
Right.
they're being multiplied by other
Oh,
things.
Yeah.
Okay?
So would cosine times arc cosine, would that cancel out?
No.
Well, here's the thing. This isn't cosine times the arc cosine. This is the cosine of
Okay.
the arc cosine. That would cancel out because they're inverses.
But since it's of, okay, I got it.
Just make sure that you're thinking of it as in terms of a composite function, not as two functions multiplied.
Okay.
So we now have root 2 over 2 times x minus root 2 over 2 times,
Wait, where'd you get the x from?
Yeah, whoa.
Did you cancel it?
right here, the cosine of the arc cosine.
Wait, I thought you just
Yeah,
said you
that's what,
cut it.
I thought
cancel
that
it out.
was
No, hang on. What I said we're not doing is we're not multiplying. This is like f of g of x, okay? Except f and g are inverse functions. Remember we saw that back when we looked at inverses. F of f inverse of x will always equal x.
He's saying you can still do it, but don't think of it as multiplying two. Like,
Oh,
Exactly.
Okay, don't think of it like that.
Yeah,
Yeah,
don't
but you
make
do
sure
it.
that you're thinking straight.
Mhm.
This isn't multiplication, this is a composite function here.
Wait,
What
where'd
do
you
you
get
mean?
5 from?
I'm confused what you
Hang
mean
on.
by multiplication. Like you're multiplying cosine times.
No,
Like,
he's
what
saying
do
that
you
we're
do
not
arc
doing
cosine
this.
squared x? Yeah. So you're not distributing, is what you're saying.
No, we're not distributing, we're using this formula right here. Cosine u is the pi over 4. Okay, that's the u. The arc cosine of x, that's our v. Okay?
Yeah, but when you say like we're not, don't think of it as multiplying, you mean like don't think of it as you're distributing, and it would be arc cosine squared x. Is that what you're
Well,
saying?
yeah. Yeah, well, don't do that either, but right here, when you're simplifying, let me draw it out here. You have this x. Arc cosine, okay? Arc cosine takes it over here as a function to whatever the arc cosine of x is. Alright? Cosine takes that value, okay? When we take the cosine of that value, it maps it right back to the x because these are inverse functions. So whatever the arc cosine does, the cosine will undo that and get us right back to x. That's the whole concept here of inverse functions.
So if we saw sine of arc sine of x, it would just be x. Okay.
That's correct. Now, when we have over here the sine of the arc cosine,
It's different.
since we don't know what x is, there's no way to simplify that, we just leave it. But we were told to find an algebraic expression anyways, so that's okay. We have an algebraic expression for
Then we're done.
Oh, so
that,
that's it.
and we're done. That's our answer. Okay?
I like these problems.
Let me use this here just to see with our tangent. Okay? We had a 1. The arc tangent took that 1, okay, and mapped it over here to the pi over 4. We know that because we know that if we took the tangent of pi over 4, we would get 1. Okay? That's kind of what you're doing in your head, all right, to figure out what those values are. And that's why, again here, arc cosine of x, when we take the cosine of that, they undo each other. Okay? Alright, yes?
So the problem when it says write as an algebraic equation, are we basically just simplifying it as much as we can?
Yeah, simplify as much as you can. Use your formula, plug in values that you can find, but you're going to end up with some x's in your answer, and that's okay.